We're on page 26, and we're looking at examples 5, 6, and 7. So that's what we're going to do now. We're going to go through these examples and explain them in detail. So the first one is problem number 5. It says find the equation of the line through the point 6 minus 1 and perpendicular to the line y equals 3x plus 7. So we know the slope of this line is 3. And what we have to do is find the slope of the line perpendicular to it. So we can do it with this formula here, m1, m2, which simply means the product of two perpendicular lines. If the first line is m1 and the second line is m2, then the product, if they're perpendicular, equals minus 1. So we know that this first one has a slope of 3. Let's say m1 has a slope of 3. Then we want to compute m2, and m2 equals minus 1/3. The other way we can do it is to simply say, oh, this line has a slope of 3. 3 is 3 over 1. We take its reciprocal, which is 1 over 3. In other words, we put the numerator where the denominator is and the denominator where the numerator is. So 3 over 1 becomes 1 over 3, and we change the sign. And that's how we get minus 1/3. So we now know that we have the slope of this line, and it has to go through 6 minus 1. So now we've got a point and we've got the slope. So here's the point. X is 6 right over here, and y is minus 1, and we put that into the point slope formula. We know m is minus 1/3. So y minus y1, when y1 is minus 1, is y plus 1, and the slope is minus 1/3 of the perpendicular line, and the coordinate of x1 right here is 6. We gave it over here again, and that gives us the equation. So here's the equation of the line. Now, we can just check this by verifying that the point 6 minus 1 lies on this line. If there's something wrong, it won't work out. So let's check it. First of all, we substitute x equal to 6, because that's the 6, into the equation that we found, y plus 1 equals minus 1/3 x minus 6. And when we do that, what happens is, for the x, we substitute the 6 right here. 6 minus 6 is 0. So 1/3 of 0 is 0. So y plus 1 is 0. And y equals minus 1. This is the value that should be obtained, because we know that if x is 6, y should be minus 1. Now, if we didn't have the right slope, then this formula wouldn't work. This is just a means of verifying the answer. So here is the answer to the equation. Let's just go over it. We are told that a line has to fall through a point, and it's perpendicular to this equation. So we will going to use the point slope formula, because we know the slope of this line. We can figure out the slope of the perpendicular line. Then we've got the point. We put it into this, and we get the answer. Now, one thing that's useful is to be able to figure out what the midpoint is between 2 points. It's not a complicated formula. Here we have it here. XM, YM, the M stands for the midpoint, is if we sum the X values, divide by 2. We sum the y values by 2. This should give us the point right in the middle between x1, y1, and x2, y2. To visualize this, let's assume this is the point x1, y1, shown with a black dot, and x2, y2 is over here, and we want this point. Now this point is right in the middle. That's the definition. It's the midpoint. X sub m, y sub m. And what we're really saying is the distance from this point here to this point will equal the distance from this to this. So it's the midpoint. So the line is divided into 2 halves. So here's the midpoint formula right here, the same one that's up here. And we want to calculate the midpoint between the 2 points minus 2 minus 1 and 4, 7. So what we do is we add the two x values, which are minus 2 and 4, right here, minus 2 and 4. We add them and divide by 2. So minus 2 plus 4 is 2. 2 divided by 2 gives us 1. And then we add the two y values, y1, y2, minus 1 plus 7 divided by 2 gives us 6. 6 divided by 2 gives us 3. Now you don't have to use the formula. You could do the calculation simply by this way. Now just don't mix up your x1 and your x2 and your y1 and your y2. So let's just go over this. This is the basic formula. We're going to use this in the next problem. It's a midpoint formula. You take 2 points. Where does the middle, what are the coordinates of the middle point? And the formula that we use is this one right here, which we've shown again right here. Okay, let's see an application of this. We're on example 7, page 26. And this is quite a long problem, so we're going to try and break it down into parts, really 4 parts that we're going to see. First of all, let's read the question. Find the equation of the line that is the right bisector. That means it's perpendicular to and through the midpoint of the line segment between minus 1, 1 and 3, 9. So here are the 2 points, minus 1, 1. And here's the point 3, 9. This is the line segment joining those points. So from here to here is the line segment. Now what we want to do is find the equation of the line that's the right bisector. What does that mean? That means that it cuts this one right in the middle. If we join these 2 points and we take the point that's right in the middle, right there, and we have a 90-degree angle. A little square here shows a 90 degrees, meaning that it's a right bisector, a right-angled bisector. So this length is equal to this length. It's a bisector, meaning it cuts the line into 2 equal halves, and the right means that it forms a right angle. So this is the line that we're looking for, this one right here. This is the line that we're looking for. So what do we need to do? The first thing is we know that it's going to go through a point here, which is the right bisector right here. I mean, it's going to go through the midpoint. So the first thing we're going to do is calculate the midpoint between minus 1, 1 and 3, 9. So here it's done. Here's the formula, and here we do the actual calculation. So we add minus 1 and 3 and divide by 2, and that gives us 1. We add the y values, 1 and 9, which gives us 10, and divide by 2, that gives us 5. So the midpoint is 1, 5, and you can see that I've shown it with an arrow right here. This midpoint lies on the right bisector. Now, since we're looking for this line, we'll need to have the slope of this line. How are we going to find that? Well, we can calculate the slope of this line and then realize that it's at right angles perpendicular to. So we can do the M1, M2 formula equals -1, or we can just do the reciprocal. So let's find the slope of this line here. So that's the second part. In the first part, A, we found the midpoint. Now we're going to find the slope of the line connecting -1, 1, and 3, 9. So that's the difference in the y's here. This is a formula we're going to use. So 9 minus 1 on the numerator is the difference in the y's. And the difference in the x's is 3 minus 1, which is 4. So we have 9 minus 1, 8 over 4 is 2. Now, 2 is the slope of this line right here. 2 is the slope of this line. But we want the slope of the perpendicular line. So we can use M1, M2 equals -1. Or we can realize is just take the slope of this, 2 over 1, turn it upside down, 1 over 2, and change the sign. So we now know that this line, the right bisector, we know the slope of this. We know the slope of it, and we know a point that it passes through, 1, 5. So we just go in, we use the formula right here. We need the value of B, and so we could use y equals mx plus b. And we're going to use this to calculate B, to find B, because we don't know what B is. We know what the slope is, we know, but we don't know what B is. Okay, so y minus a half x plus b, and it falls through the midpoint, which is 1, 5. So y is 5 and x is 1. So here's y is 5, and for x we've chosen 1 plus b. And so if we multiply through by 2 here, we multiply through by 2, we get 10. This is -1, and this is 2b. Now we multiply this line through by 2 because we don't want a fraction. We've got 2 on the denominator here, so we multiply each term by 2. 2 times 5 is 10. 2 times minus a half is -1, and the b is 2. So we transpose the -1 from the left to the right. We get 11 equals 2b. Divide by 2 here, and b equals 11 over 2. Now, again, we can check the answer by realizing that the midpoint must fall on the line, on this line. And if there's something wrong with a slope, for example, it won't work out. So what we're going to substitute is x equal 1 into the equation. And if we put 1 here, we get minus a half times 1 plus 11 over 2. Take the common denominator as 2. We get minus 1 plus 11 gives us 10. 10 over 2 is 5. That's what we should get. We didn't have the right equation. We wouldn't get that y equals 5 when x equals 1. So let's go through this again. We know there's a line segment joining these 2 points. We first of all calculate where the midpoint is. That's 1, 5. Then we calculate what the slope of this line is, right over here, and we find it's 2. We now know that the right bisector has a slope of 1/2. So we want the equation to equal. We want to find the equation, so we know y equals mx plus b, but we don't know the value of b. We can find b by substituting 1, 5 for y, and 1 for x into the equation and finding b. And that's when we find b is equal to 11/2. So there's 4 parts to this. The midpoint, we need a slope line, a slope formula, we need a perpendicular slope formula, and finally we need to be able to calculate b. So in the last part, find b in the equation y using the slope m calculated in part C above, and the coordinates of the midpoint between the 2 given points. So you have to be able to understand this diagram. This is a very important diagram, and to see that you've got these 2 points here, and here's the right bisector.